Can you see my screen, people?
Yeah, we can.
Okay. So this is one of the questions where 2016 AMC 8's 2020 edition. It was problem 6. So Aaron, Darren, Karen, Marin, and Sharon rode on a small train that has 5 cars that seat 1 person each. Marin sat in the last car. Aaron sat directly behind Sharon. Darren sat in one of the cars in front of Aaron. At least one person sat between Karen and Darren. Who sat in the middle car? So your options are Aaron, Darren, Karen, Marin, and Sharon. So step 1 is getting your data. We already know who occupies the last seat, as the question states that Marin sits in the last seat. Now the question also states that Aaron sat right behind Sharon. So we know that row 4 does not house Sharon and row 1 does not house Aaron. There is also a distance of at least one seat between Karen and Darren. Sharon can sit on the seats 1 to 3. Okay, so filling in the blanks is our second step. If we know already that the 4th seat cannot have Sharon or Karen, then we have the option of Aaron and Darren. We must fit the conditions of Aaron having to be behind Sharon and at least one space between Karen and Darren. So if we fit Karen on the 4th seat, Aaron on the 3rd seat, Sharon on the 2nd seat, and Darren on the 1st seat, then yeah, that's the question solved. We know that Aaron sits in the middle seat. The theory we used was logic and trial and error. Both theories can be used. So trial and error is just going at the problem until you find the solution, and logic is just using reasoning and lots of different attempts. Logic is just correct reasoning and making correct decisions based on your data. Yeah, that's the first questions. Does anyone have questions? Or no? Okay, I'm gonna go to the next question. Wait, can you see my other Google slides or no?
Yeah, we can see it.
Yeah.
AMC 8, right? Question 11, right?
Yeah, question 1.
Okay. After school, Maya and Naomi headed to the beach 6 miles away. Maya decided to bike while Naomi took a bus. The graph below shows their journeys, indicating the time and distance traveled. What was the difference in miles per hour between Naomi's and Maya's average speed? So your options are 6, 12, 18, 20, and 24. Step 1. Naomi was able to do 6 miles in 10 minutes, which is a sixth of an hour, and the ratio being 6 to 10. If we multiply both sides of the ratio by 6, we have 36 to 60, or 36 miles per 60 minutes, or 1 hour. If we use the same formula for Maya's speed, Maya did 6 miles in 30 minutes, which is half an hour. Our ratio is 6 miles per 30 minutes. Now, because 30 minutes is half an hour, we can multiply both sides by 2, and we get the result 6 miles, or 6 miles to 1 hour or 60 minutes. Our final step is that we just need to compare.
Frankie, did you mean 12 miles? You said 6.
Yeah, 12 miles. Yeah, sorry. We multiply both sides of the ratio by 2, and you get the result 12 miles to 1 hour. Okay, yeah. Final step. We have already put both speeds into miles per hour. So now we can simply subtract Naomi's speed by Maya's speed. So we subtract 36 by 12, which is 24. Therefore, the difference in miles per hour between Naomi and Maya's speeds is E24. Okay, the theory I used was ratios and rates. A ratio indicates how many times a number contains another. So an example would be 20 boys in a class to 19 girls in a class, making the ratio of boys to girls 20 to 19. It's helpful to think of a ratio as a scoreboard in a sports match, like I don't know, 1-2 is the score, and like Blue Jays versus wait, I don't know, like some other baseball team. Yeah, that's all for me.
Very good job, Frankie. Does anyone have any questions about that? Or different solutions? I'm gonna take it as no one has any questions. Okay, I'm gonna present now. This question, first off, is the 2019 AMCA Problem 2 question. The problem is, if 3 identical rectangles are put together to form rectangle ABCD, as shown in the figure below, given that the length of the shorter side of each of the smaller rectangles is 5 feet, what is the area in square feet of rectangle ABCD? A, 45, B, 75, C, 100, D, 125, and E, 150. The solution is using the picture of the rectangles here. We can find that longer sides of the smaller rectangles are twice the length of the smaller sides. If you look here, it's basically double the size. So given that the shorter side of the rectangle is 5 feet long, the longer side would be 10. Now that we've calculated, now we calculate the longer side. To make like the long side, it shows that one long side of a rectangle and one short side of another, which is 5 plus 10, which is 15, which makes it 15 feet long. And 15 times 10, which is 150. So that's answer E, 150. So it's 150 feet. Well, the area is 150 in square feet. Does anyone have any questions? I see that Ethan has a different solution. If you want to explain that, then you can unmute and okay, so you don't want to explain that, then does anyone have any questions or like other solutions that they want to explain? I'm guessing no. Okay, I'm gonna move on to the next question. Okay, this is 2020 AMCA problem 4. 3 hexagons of increasing size are shown below. And below the dot pattern continues so that each successive hexagon contains one more band of dots. How many dots are in the next hexagon? A, 35, B, 37, C, 39, D, 43, and E, 49. The solution is the first hexagon has 1 circle, and the second one has 7, adding by 6. The third one has 19, adding by 12. If the increasing pattern adds by 6, like every time, then the next hexagon should be 18 plus 19, which is B, 37. Does anyone have any questions or different solutions?
Is it, wait, can you flip to like the page where there's a pattern?
Yeah.
Isn't like the circles 1, 3, and 5? So can you assume that the next one is 1, 3, 5, and then 7, and then calculate from that?
What? Well, if you're gonna go from that, then I think so. I guess so. I think you can. Since the increasing pattern was already displayed in the previous numbers. So I don't think does anyone have any more questions?
No.
All right, I'm gonna move on to the next question then.
All right. Yeah. So I think we are done. You guys.
No,
Good.
we aren't, bro.
Yeah, no,
Still-
we aren't, bro.
Oh wait, no. You still have. Oh wait, sorry.
You tripped it. The last question is 2019 AMCA problem 14. Okay, so Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Treats. In order to make the coupons last, she decides that she'll redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 days on her calendar, she realizes that no circled date falls on a Sunday. What day of the week does Isabella redeem her first coupon? A, Monday, B, Tuesday, C, Wednesday, D, Thursday, E, Friday. The solution is we need to loop 10 days through all of the days of the week. To solve the problem, we need a full 6-day chain with no Sundays. Monday would be Monday, Thursday, Sunday. And since Sunday hasn't been counted in her calendar, Monday wouldn't work. Tuesday would be Tuesday, Friday, Monday, Thursday, Sunday. And that's only 5 days. So Tuesday wouldn't work either. Wednesday would be Wednesday, Saturday, Tuesday, Friday, Monday, Thursday, which is a full 6 days without any Sundays. Thursday would go straight to Sunday right after, and Friday would be Monday, Thursday, Sunday. Like Ethan said, we use trial and error for this. Does anyone have any questions? Or different solutions that they have? If not, then the slides are done. And